Today we will talk about something different. Today we will try to expose the trigonometric effect of music and musical effect of trigonometry without using the sinusoidal waves. Here we will try to show that the MIDI file is kept in this folder here and no other files are there. The exe file is placed here, which is the Geometrifying trigonometry simulator. And first we will listen the music in the MIDI format. There are the waves, and these waves are not actually waves. These are all the playing of tracks, and these tracks are with different frequencies. We have made a model such that the different frequencies are taken as the radius. Every note number of any MIDI sound has a frequency, and all these frequencies are plotted in a circular domain where we will get the piecewise line segments due to the start time and end time. We all know that MIDI stores the time with mega microsecond. Mega microsecond means 10 to the power minus 6 second into 10 to the power 6, which means 1 second is divided into 60,000 microseconds. And when we divide it with the micro tempo, then we get the BPM, that is the beat per minute. And when we divide the 60,000 with beats per minute, then we get the micro tempo in a MIDI file. Whatever the size of the MIDI file, whatever the duration of the song is, we can think it as normalized to 360 degree, and the frequencies are taken as a radius, and 360 degree total turning is taken as the total time span of the music. In this way we can interpret the whole cycle of music with whatever 128 number of instruments with 10th channel for the percussions, and every of the notes have a frequency. With the instruments we get the different timbres, but with the instrument change, that is with the patch change, we don't get the different kind of frequency at all. Frequencies are dependent upon the octaves, and the frequencies are dependent upon the note numbers. There are 128 note numbers, and for every 12 notes the new octaves come, because it is the 2 to the power 1 by 12 into 2 to the power r. R is from 0 to 12, and so one octave completes in that way. But every note has a particular frequency, whatever the instrument we are choosing for that. Now we have listened the music, that these are the music. I have taken a sample here, and we will try to generate the geometry for this. Okay, now we will copy this path, open this tool. You can see that there is no drawing file present here. We will open it. From this music we will get the engineering drawing. When this tool opens, first it shows us the frequencies available for the note numbers. These are the note numbers, and the corresponding frequencies are there up to 128, 0 1 to 128, 0 to 127. The first row is there for the heading, and so it is coming as a 129. For every note number there is a note name, and there is a corresponding frequency. And for the frequency 440 Hertz, you can see that here these frequencies are taken as the radius in my model of Geometrifying trigonometry. We are trying to generate the music with the images generated with the Geometrifying trigonometry, like these kind of images which we get in the Geometrifying trigonometry, that in other videos we have demonstrated already, that we are getting multiple number of line segments, and for every line segments there is a distance from the center, and that is giving us the frequency. And when we generate these patterns, and then we can generate the MIDI files out of these trigonometry problems. We will open this path here. You will see that when we will select the MIDI file here, then it will take some time because my system is slow. It is reading the MIDI file. It reads the binary MIDI file, and from that it has found that 16,668 numbers of MIDI notes are present in this whole music. This much number of times the MIDI notes are on and off, and every note has the duration. Every line segment in our model shows the duration. The length of the line segments are the duration. The distance of the line segment from 0, 0 is the frequency, that is the note number for that particular line segment. The color is dependent upon the channel number and the track number. Here we are getting a small version of description, whatever is present inside the MIDI file here. The lyrics tracks are also read here, and those are present with the time in the microsecond. These values are the absolute time, and here we have taken the absolute time, we have taken the duration, we have taken the patch changes, or we have gathered all the meta events also, we have gathered the channel events also, and then we have made a synopsis of this and tried to generate the geometry of the line segments arrangements. You can see that in the CAD viewer. Let's see the output. The DXF file is generated here. We will open that DXF file, and then we will see the beauty of this output. Control O, Control V, going to that path. The same name of the file is generated. We will do the zoom, Z space, E space. This is the arrangement which forms. We will do the panning on this image. That is not sound panning, that is the engineering drawing panning. Here if you see, then all the line segments are distributed around 0, 0. These line segments, these small line segments which are near 0, 0 have the lower frequency. This is the metronome. There is a channel 10 which is for percussion. The red colored lines, small lines, these lines are maintaining the tempo, these red colored lines, and all other lines are also generating here. The farthest lines are with the highest frequency, and they are played in the intermittent way. The length of these line segments are showing the duration, and we can cross verify the length. The length here, you can see the length here is 104886, which is in the 1000 scale. I have tried to make it in the 1000 scale. That is 1048. You can cross verify that with the dump that I have already shown there, because we can try with multiple different kind of MIDI files in the next videos, and I will try to show the arrangements of Rabindra Sangeet also, with the Nazrul Giti also, with the kind of interpretations in the trigonometric forms, and all these will have a trigonometric relationship like this, and triangles are formed at every position, and we will analyze all the music in this way of progressions, and with these progressions we can generate the triangulation maps, and from these triangulation maps we can get the music in the reverse sense. As you have seen in my previous videos, the trigonometry turns into the line segment geometry, and this line segment geometry has a full potential to generate the music with proper meaning with proper arrangements. And that's it. Today's video is only to show this part, that we can interoperate the geometry with music and music with geometry. Thank you.